Good morning, class. Today we're going to go over 0.1, which is like an introductory chapter to precalc. It's called sets. It's very theoretical. It's also pretty fun and useful depending on what career you're going to choose. So to begin, what is a set? A set is pretty much a collection of elements or objects. Now, they can be related, they don't have to be related, they can be numbers, they can be colors, they can be actual real life objects. So pretty much a set is just an accumulation of elements. Let's go over a couple of examples. A set could be the students in this class, and each student would be an element. So in this case, they're more or less related. A set could be the pages in a book. And, they're more or less related, and each page would be an element. The movies in Marvel cinema, the Marvel Cinematic Universe, that could be a set. Each movie would be an element. However, there doesn't have to be a relation. You can just say all the actual physical objects in this country. You could have people, you could have cars, you can have trees, even though the relation is in this country, but you can see that the objects don't actually have to be identical or similar. It's just a collection of elements. So that is the definition of a set, a collection of elements. Now, element is pretty much each individual, each object in a set is pretty much called an element. Again, pages in a book, students in a class, people in a country, trees in a forest, cars in a parking lot. So each individual object is called an element. Now note, some of these objects don't have to be physical, like the numbers in the whole number universe, the whole number set. There's not an actual number one, but it is an object in that set. To proceed, you will have to know what certain symbols mean in order to we're going to go over these two first. The first one, which is like a curved E, you can see in the book in page 3. Pretty much what this means is belongs to, and you'll see how it works right now. And this one here with the same symbol with the line crossing it or the dash means does not belong to. If you go over to example 1, they ask you certain questions. For example, if we look at the first question, it says, n is the set of whole numbers greater than 12. So n is greater than 12. And at the same time, n is also less than 16. So this particular set is the whole numbers greater than 12 and less than 16. If we follow the rules, we know that the next whole number is 13, bigger than 12, 14, bigger than 12, and 15, bigger than 12. The sets are always closed by keys. The keys are the ones with curves, the brackets are the ones that are straight, and pretty much the numbers that make up this particular set are these three elements, 13, 14, and 15. Now you can see the question A says, pretty much this question, does 15 belong to n? If you look here, 15 is right there. So you would answer true. 15 belongs to this set of n, the set of n being whole numbers greater than 12 and less than 16. If we want to see it in an easier fashion, I can say, for example, do horses belong to the mammal, I'm sorry, I'm not a biologist, the mammal species or mammal class or kingdom, I can't remember. Are horses mammals? True. And for example, is a particular student belong to this class too? Do you belong to pre-calculus class? True. Do you not belong to pre-calculus? False. Now, let's use the second element. If right now I ask this question, does 15 not belong to this set? It would be false, because 15 does belong to this particular set. So you're going to have to pretty much answer these questions in a logical way. Let's go over example B. If B states, let me go ahead and erase up here. B states V is the set of vowels. Pretty much all the vowels. If we go over the vowels, I have A, E, I, O, U. And the question that they're asking me, does the letter G belong to the vowel set? And of course, the answer would be false. G does not belong to the vowel set. If I were to switch this question and change it to this, does G not belong to the vowels? Then it would be true, because G does not belong to my vowels. So now this question would be true. Again, start getting used to true and false, yes and no, etc., etc. Let's go ahead and erase these elements right now. Sorry about that. Let's continue. And let me go ahead and erase this set. We won't need that one anymore. Let's go over the following question. Question C in example 1. It says, M is the set of months that begin with the letter J. M is the set of months that begins with the letter J. And they're asking me, does April belong to M? And again, remember, M was the set of months beginning with the letter J. Does April belong, or does April begin with the letter J? No. So April does not belong to M. This question would be false. And again, if I were to say does not belong, April does not belong to the group of months starting with J. So when I ask does not belong, it would be true. Let's go over the last example. The last example states X is the set of numbers on a die. I will assume it's a 6-sided die, because there are die that go all the way up to 12, 20, a whole bunch. So X is the, and also their die, well, I think the smallest I've seen is 4-sided die. So X is the set of numbers on a die. And the question is, does the number 4 belong to the possible outcomes of a die? The answer would be true. 4 does belong, assuming it's a die with numbers. Some dies have symbols and colors. Pero yeah, it does belong. So pretty much, that is how we use belongs to and does not belong to. Pretty straightforward. Okay. Now, let's go over these 3 concepts, because here we're going to be using this symbol. And this symbol means subset. A subset is a smaller set within a bigger set. For example, if I say the set if are the students in this class, a subset of students in this class could be maybe the male students in this class. Male students in this class would be a smaller subset within the set of students in this class. Or if we take the example of a book, the set could be all the pages in the book. All pages in the book. A subset could be pages in chapter 1, pages in chapter 2. Or you can even have subsets of subsets. You can say even numbered pages in chapter 1. So you can have as many subsets as you need, actually. And that helps us separate and organize sets. Now, there is one set called the universe, and the universe just states what are all the possible elements within that group. For example, if I say letters in the alphabet, that is the universe. Does A belong to the universe of letters in the alphabet? True. Does 1 belong to letters in the alphabet? False. So a universe is pretty much all the possible elements, not necessarily the elements that are used in your particular set. For example, if I say my universe is all possible real numbers, I can have a set that's just, numbers 1, 2, 3, and 4. That is my set. That is a subset of the universe set, which is all real numbers. It's perfectly fine. So why do I need to know what the universe is? So we can work with complement. So we already know what universe is. We know what a subset is. But what is the complement? Now, the actual definition of complement, I don't know the literal definition, but it's pretty much what a particular thing is missing to become whole. You know, what something is lacking to be complete. So the complement is what my actual set is missing to become the universe, because universe is everything. A set could be equal to the universe. Let me give you a couple of examples. Let's say I'm stating right now that the universe is all whole numbers from 0 to 9. 0, 1, 2, 3, 4, 5, 9. That is my particular universe for this problem. My universe is whole numbers from 0 to 9. Now, I can have a subset of those numbers. Let's say my subset is 1, 3, 5, 7, 9. I chose all the odd numbers because I felt I like it. Doesn't have to be a whole number, all odd numbers. I just felt like it. I want this set to be, or this subset of the universe to be all odd numbers from 1 through 9, including 1 and 9. Now, let's say I call this set O. We always name our sets with capital letters. I chose this O as odd. It just helps me identify it easier. Now, complement is, the symbol of complement is like a small apostrophe on the upper right-hand side of the name of the set. So, if this is my set O, and I were to ask you, what is the complement of O? What is the complement of O? Now you ask yourself, what is O missing to become the universe? All O is missing to become the universe is the even numbers. So the complement of O would be 2, 4, 6, 7, 2, 4, 6, and 8. And I am done. When I put these two together, I get the universe. So that's what complement means. What a particular set is missing to become the universe. Now note, if I want the set n to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I ask you, what is n? What is complement n? What is the complement of n? What is n missing to become the universe? Well, no, n is identical to the universe. So what is it missing? Anything. Make sure you label it as literally an empty set, or you can use this symbol that represents empty. Please do not say, well, it's not missing anything, so 0, it's not missing anything. No, because the 0 is an object or an element within this set. I have 0 here, I have 0 here. So it is not missing the number 0. Use empty, not 0. Empty or just an actual empty bracket. So that takes care of set, element, universe, subset, complement. Belongs to and does not belong to. Now, another way we can ask questions is, for example, let's use these exact same groups. This is the universe. If I were to ask you, is n, which is 1, 2, 4, 5, is n a subset of my universe? The answer will be true. Every element created using the elements in the universe will always be a subset of that universe. Pero, let's create now different sets and let's see what happens. Let's say I have another set, Q, and I just have 1, 2. And I have another set. Let me go ahead and write it here so you guys can see it. I have another set called R, and R is 5, 6, 7. Note, all these sets are created using objects in my universe. Now, if I were to ask you, is Q a subset of N? Make sure it's rounded like this. Is Q a subset of N? Is Q contained within N? True. 1, 2, and I have 1, 2 here. Now, if I were to ask, is are a subset of n. R is 5, 6, 7, and n is 5, but it does not have 6, 7. So this would be false. R is not a subset of n. And that is pretty much it for subset. Now to finish, we're just going to go over union and intersection. Union is simple. You can use this symbol that looks like a capital U, but it's not really a capital U, it's just union. And say, for example, I have sets A, 1, 2, 3, 4. I have sets B, 1, 5, 6, 7. I have sets C, 3, and 4. If I say, for example, A union B, all you have to do is put all the elements together, but you do not repeat values. For example, the set A union B would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You do not repeat number 1, even though it is repeated here. Even though they both have number 1, it is not repeated. Now, let's say, for example, B union C. B union C. I have 1, 3, 4, 5, 6, 7. 1, 3, 4, 5, 6, and 7. So pretty much putting all the elements together and no repetitions. That is union, represented by the symbol that looks like a U. The last symbol we're going to go over today, and this is going to be the end of the class, is intersection. When you think an intersection, people think streets, where streets cross, where two lines cross. So intersection is pretty much what things in common do my sets have. For example, and I do apologize for erasing the sets. I should not have erased them. 1, 2, 3, 4, 5. And B is 1, 3, 5. And C is 2, 4. For example, if I state now, what is A intersection B? Let's see, they both have 1 in common, they both have 3 in common, and they both have 5 in common. So A intersection B would be 1, 3, 5. What would be B intersection C? They have nothing in common. So either an empty set or an empty set. I'd rather do it like this than just leave it empty. That's just a preference, but it's the same thing. Doesn't matter. And to finish off, what is A intersection C? Again, C does not have 1, but A has 2 and 4, and so does C. So the answer would be 2, 4. That's pretty much a rundown of a small introduction to set theory. We will dive a lot deeper into set theory when we actually go over chapter 1. So stay tuned. Great job. See you soon.